Juliet, Whiskey 3 Romeo Juliet.
Okay, so you guys are probably wondering why I have this Regen set up. Well, this week I want to go through the Kitchin Regen. The Kitchin Regen has been a popular project since it was published in 1998 in QEX, ARRL, for their little more in-depth research type projects. So you'll find all kinds of interesting things in QEX. But eventually the Kitchin Regen found its way into the handbook as a standard kind of solid-state intro receiver. Kind of a throwback to the old days of the handbook, where they had very simple projects to get you started as a novice on the air. So this is not a fantastic build that took months to build. It was built over a weekend, literally, and it was done in the Manhattan-style, island-style construction, where you take a piece of double-sided circuit board and you kind of carve out islands with your Dremel tool. That's the way this one was built. The Kitchin Regen has been innovated on, and many, many versions of the receiver have been produced over these 30, 40-some years since it was introduced to the hobby community, the ham radio community. And this is a ham receiver. Unlike receivers that are meant to hook up to 25 or 30 feet of wire hooked around your apartment, this is a real receiver that's made to work with 50 ohm type ham antennas like dipoles and end-fed half waves and things like that. So it's a little higher performance than the normal hobby style Regen, where you have maybe one transistor and one amplifier. This guy sports a common base RF preamplifier, and we're going to go through that circuit, as well as the detector circuit, which uses a JFET. So in this video, you're going to learn about Chuck himself, the guy who designed this. I worked with Chuck in the 1990s. And you're going to learn about his design ideas and his philosophy of construction, really his way of thinking on projects. He wasn't going for high performance, use as many parts as you need to get there. He was going for more like the minimal part count, the simplest form of the circuit that gets you there. He was the kind of guy that would look at one of my circuits and probably remove half of the parts. And he'd make a statement like, "Mike, nobody will ever build your circuits. Too many parts. Anything over 10 parts, forget it. Nobody will touch the circuit." So here it is. This is a little bit of a retrospect for Chuck Kitchin. Charles Kitchin passed away about 3 weeks ago. He is a force to be reckoned with, and we'll do a little backgrounder on Chuck first. Then we'll get into his very cool regenerative receiver. So Chuck's love of simplicity, okay? Mike, nobody will build your circuit because it has more than 10 or 12 parts. That was his thinking. Kids, experimenters that are just starting out will not touch a circuit that has any more than a handful of parts. And these parts better be common parts, by the way. The kind of parts you could get down at Radio Shack at the time. Not the kind of parts that involve really fine soldering or surface mount or chips. His favorite chip, of course, was the LM386 because, you know, you got a bypass capacitor, you hook the thing up and it just works, okay? So even though the LM386 is a horrible chip as far as noise goes, it's easy and it's readily available, so that was a winner for Chuck. So a lot of his circuits were oversimplified to the point where they were frustrating to people, drove people nuts. He chose simplicity over performance. Now, the exception to that were a couple of circuits he did. Of course, the obvious one, the high-performance receiver that he published in QEX and later on in the handbook. Number one, that's an ACE. You know, that works out of the box, and it is high performance. Also, his super regenerative receivers, operating in the VHF aircraft band and so on. Those worked fine. But a lot of these simple one transistor bipolar regens, and I am going to say that I'm guilty of contributing to that. Chuck and I did an article in the QST 1997, I think it was the May edition, 1997 May, called an ultra simple W1AW receiver. Ultra simple meaning, 10 or 12 parts maximum. And I remember the coil was wound on a film can and so on. Well, this was a basically oscillator that we inserted a crystal in series with the feedback, and then you kind of control the regeneration of the thing. And it wasn't very stable, but because you had a crystal, it stayed on frequency, and it was a color burst crystal. So it was just off W1AW's frequency enough that you could get a tone. So it worked. It especially worked here in New England, where we had a single hop, or we had ground wave for W1AW's code practice. But if you got outside New England into Ohio or further out, the thing utterly didn't work because 80 meters didn't skip that far when W1AW did their code practice. So that was the problem with that circuit. But somehow he took that and developed that into something called the Scout receiver, which was a kind of a bipolar Hartley regen. And that thing does not have good feedback or a good reputation. And unfortunately, a circuit board was made and it was sold at one point. Now, the circuit board for the high-performance regen, that would be a winner, and I'm not sure if that's available anymore. That's why I'm going to be doing that along with tube head designs, and we're going to make it available that you can actually build the high-performance regen on a circuit card. The next section, we're going to go through Chuck's upbringing, his military service, how he became a technician and eventually got his associate's degree, and then he became a pretty prolific author. So here's a little backgrounder on Chuck. So let's talk about Chuck a little bit. He passed away on March 17th, 2025 at age 77. So that's about 10 years older than I am. I've referenced his obituary, all about his family, his wife, and so on, and I'll link that in the description. But here are a few tidbits about Charles Chuck Brainard Kitchin, N1TEV, who lived in Billerica, Massachusetts. So first you have to know that Chuck was a Yankee through and through, and he had all of those regular New England traits, including being very opinionated and thrifty, of course. He was born in Somerville. Summer here, summer gone. That's a Boston thing. Chuck solved problems in the most simplistic way. He'd been tinkering with electronics and radio since he was a kid. He managed to pass his FCC exam and worm his way into a radio station engineering position in the 60s. WCRB, kind of a classical music station in Boston. There was a problem looming, though: Vietnam and the draft. To solve this, Chuck figured out a foolproof plan: volunteer to join the Air Force, go to the Arctic. So this ploy really worked, and it was an almost automatic posting to the Arctic Circle. While in the Air Force, Chuck was stationed at Tuli, Greenland, where he ran the radio station and played his favorite music, repaired equipment, and so on. But he entertained the troops during those long, dark, cold winters. And yep, the booming radio voice was honed as he was an announcer at a radio station. After being discharged from the Air Force, he got a job back at WCRB, and he also started attending Wentworth Institute to get his associate's degree. He was a recording engineer for live broadcast of the BSO, that's the Boston Symphony Orchestra, at Tanglewood. Upon completion of his associate's degree, he began to work at Analog Devices as a technician in the design department. Of course, Chuck was a ham and a shortwave radio enthusiast, but he was also a gifted oil painter and a music nut, especially for obscure 1960s music. Chuck was a man of many passions. He was a kind and generous person, though, and more than willing to help anyone in need, especially in his community when he saw that the local school systems needed more STEM education. And he was an amateur astronomer and built 3 high-powered telescopes. I remember telescopes set up at his parties for folks to see Saturn or whatever interesting celestial thing was visible at the time. And did I say party? Chuck's parties, called DBs for Despicable Barbecues, were a nerd explosion with all kinds of folks from the Boston electronics scene, 128, Beltway, and unsuspecting invitees, even neighbors. All were subjected to the nerds that Chuck held court with. One tradition was to have people show off their latest projects to the group. Chuck had challenged me to build a squelch for the Heath tour. He said, "Why don't you do it with a solid-state super regenerative receiver?" So I got this circuit together. My super regen hissed like they all do. It was sensitive in the aircraft band, so I worked on this squelch circuit for, maybe 3 weeks. I did up a simple circuit using a quad op-amp, the last stage of which was a comparator that would upset the LM386 and mute it. Hey, it worked. I brought it, I demonstrated it to the group, and typical Chuck. He says, "Nice work, Mike, but nobody's going to build that. It's got way too many parts." That's classic Chuck. So I really had to dig deep into the junk box to actually find this thing. I did find it. It was buried in the bottom of a bunch of discarded old projects, old circuit boards mostly. And I actually found my crude schematic diagram. It's an interesting circuit. It has a common base amplifier up front. Into a super regenerative receiver. Both of these are bipolars. And the output of the super regenerator goes into of course, an LM386 to the speaker, but we also tap the audio off into this chain down here consisting of the the old LM324? Yeah, the old quad op-amp, bipolar op-amp, to a couple of stages of filtering. And this filtering is looking for the noise in the background when there's no station, the hissing, in other words. And then we go into a super detector. This is a 2-diode op-amp rectifier. And then into the last section, which is the comparator. And that comparator upsets the bias of the LM386 by jamming a positive signal into the negative, and that cuts off the LM386. So that's the squelch circuit. Here's the squelch control. And basically, that's it. It worked. Chuck, of course, declared this thing way too complicated, and he came up with his own circuit. Let's take a look at the circuit he came up with. So this circuit was published in QEX in September of 2000, and the super regenerative detector with the squelch in a VHF aircraft band receiver. Now Chuck has gone to JFETs here, and he's using the common base JFET preamp, probably because it's fewer parts than a bipolar amp. So saving one resistor is a reason to completely change for Chuck. The fewer the parts, the better. Then he goes into a common gate super regenerative detector and into a conventional filter that goes into the audio gate FET Q3. And he splits that off and he goes into a high frequency filter that he sends into the LM386 that he's using as a squelch amplifier. And the squelch amplifier goes into a voltage doubling detector, turns it into a negative DC voltage that cuts off Q3, and acts as the squelch gate into the LM386. A pretty elegant circuit. It uses two LM386s, Chuck's favorite chip, and there's no need to worry about op-amps. And this is a simpler circuit, and he preferred this circuit. much more simplistic than the one that I came up with. It's really good to see how he solved problems with using very, very simple parts. I joined Analog in 1996 and met Chuck almost immediately. You heard him before he entered the room with his booming voice, of course. Chuck figured out that Analog Devices would pay him to write articles for commercial magazine publication. You mean I'm going to get paid? So the extra cash, he liked that. He was in. This started his career in technical writing and hobby project articles. Finally, Chuck transitioned from a tech to a technical writer at Analog Devices, doing a lot of app notes, interesting articles about chips, and so on. But this killed his payday. He could no longer get paid for the articles, and he mightily griped about this. Over the years, Chuck had published countless articles and wrote 3 books that have been translated into several languages. So finally, here are a few life lessons from Chuck. 1. If you're having fun, then people will want to hang out with you. Get that, nerds? The wine tastings and the Christmas parties and the swamp DBs are legendary. And the reason is, it was always fun to go to visit Chuck at his house. The music from the 60s got people in a good mood. Chuck recorded many tapes of the 60s music, and he'd play this. The wine tasting was fun. We'd be debating the nuances of cheap swill as the sensibilities of the participants became gradually more and more impaired. And Chuck had a guaranteed method to judge the best wine of the night. It was the bottle that was empty first. Number 2, include everyone. The Christmas parties were a cross-section of humanity. Chuck invited everyone, and they all came. It was easy to get trapped in a small clique of friends and not see other walks of life in the electronics industry. But Chuck didn't do this. He didn't care. Everyone was welcome, and he wanted to share everything. 3, give back. Chuck was dismayed that there was very little science taught in the local middle school, so he volunteered to teach it himself. The support of Analog Devices was most helpful to give him the time needed to teach and prepare, so an outgrowth of his teaching activity was the annual science fair. Chuck recruited many people to go into the school for a whole day to put on demonstrations for the kids. And of course, all the nerdy engineers love showing off their toys. Number 4, keep your eye on the donut and not the hole. Okay, so you want to make a 1-transistor radio. Here's a 1-transistor radio. You've got your nice diode detector with a proper bypass capacitor and a return. This is a good circuit. It's cap coupled into a properly biased transistor audio amplifier into the headphones. Now Chuck would say, yeah, that's nice, but I can do it with this circuit. You're not going to the moon with this radio. You're not at 0 degrees Kelvin. My radio works just as well, and it has almost no parts. So this schematic from QEX in the year 2000 is probably the most popular of Chuck's designs. It's somewhat different than the original 1998 version that used the PNP RF amplifier and a low-noise op-amp to drive the headphones. Chuck griped that nobody wanted to source an expensive Analog Devices op-amp, especially one that required a bipolar power supply. That is 2 9-volt batteries in this case. So he was talking about how people want to be able to go to Radio Shack, or they want to be able to use really popular parts. So he substituted in the LM386 audio power amplifier chip. And he also converted the front end into a 2N2222 NPN front end amplifier in the same common base preamplifier circuit that he used for the PNP. So even a PNP transistor was deemed too exotic for a lot of builders. He added in the 1N4004, kind of a poor man's Varactor, as a fine-tuning idea. Anyway, it's this schematic that got everything going in the hobby builder community, and there was quite a following. This circuit does solve a lot of things for you. And even if you're building this in a quick way, and you're just quickly soldering something together over the weekend, this kind of a circuit gives you a lot more chance of success than many other types of regen circuits. First of all, the isolation attached directly to a coax-fed ham-type antenna makes it different from most regens. In other words, you just don't attach coax to a trimmer capacitor and attach it to a high Q-tuned circuit like most regens are. In this case, he's put an attenuator right up front in the form of that 1K potentiometer. He's using a proper common base preamplifier, and that gives you a nice low impedance input. This is going to give you a very nice front end for a regen. By the way, the common base amplifier is an excellent match, not only for 50 ohms, it also works with long wire antennas. It gets you away from all those bad antenna effects with resonances and things like that you normally get with trimmer coupled regens. This common base amplifier is a little odd to some people. They're not used to seeing common base, but this topology has a fantastic bandwidth. It doesn't suffer from the Miller effect, so it allows a transistor to operate well into the VHF region. And you would think that most of these audio general purpose popcorn parts would give up, but in common base they work right up through the VHF region nicely. This is also a low noise amplifier, and it has high signal handling characteristics. Doesn't require neutralization usually. Being an engineer, I didn't like his biasing technique of just tying the base to plus. The other negative about doing that is it forces the input to be at a very low impedance on the order of 10 ohms. So because I'm kind of religious about biasing, I improved it by making a proper voltage divider on the base. I think I used a 10K and an 8.2K resistor and put 3 or 4 volts on that base, of course retaining the bypass capacitor. And this raised the impedance of the input on the common base amplifier to much closer to 50 ohms. The JFET feedback detector is a standard. It's a beautiful regenerative detector. But notice how Chuck takes the detected audio off the source of the transistor rather than the drain or the tickler side. This does give a bit less audio output, detected audio output, but it greatly increases the isolation between the ports. So you end up getting less pulling off frequency when you're playing with the regen control with single sideband signals. Other than that, this is a pretty straightforward circuit. The LM386 is great. You've got a little bit of audio filtering for lowering the frequency so you can listen to CW without a lot of hiss and noise. You do need filtering, by the way, for the LM386 because it's kind of a noisy chip on headphones. Into a speaker, it works just fine. You really don't notice the noise. So this circuit worked out great. There's been umpteen modifications and variations on this circuit, and I think it goes a long way for someone who just wants to try a regen that might work okay on the ham bands to do CW duty or even single sideband listening. If you put a good stout front panel on this, like a 1/8 inch aluminum front panel, and ground everything really well to a double-sided circuit board or maybe a ground plane sheet on the base, you're going to have a very good regen. Putting this into a fully shielded enclosure, of course, that'll work as well. And anything you can do in terms of vernier dials makes the regen better as well. Now, there is a difference between the original, which used a 5-pin plug-in coil, and probably what you should do with this one that uses the NPN front end. You're going to need to use probably an octal plug-in coil if you do use plug-in coils.
So I have the generator hooked up to the input of the receiver. It's teed off to the A channel of the oscilloscope, and I've got the 10X probe attached to the collector of the preamp. We're trying to look at just the gain of the preamp, or at least the gain of the preamp into the tune circuit. I've disabled the regenerative stage. I'm looking at the collector of the common base amplifier. We're putting a signal into the receiver and looking at the output of the preamp. Now the first thing you notice is there is some gain showing, but it's not the 18 or 20 dB of gain that we expected. We are of course getting some gain out of the stage, but we're limited by the impedance match into the detector. So tuning the detector does have an effect. You notice how the two signals are in phase. This is characteristic of the common base amplifier. There's no inversion. In a common emitter amplifier, you have a 180-degree phase shift. With a common base, there is no flip. Now, once we hook up the detector and we get regeneration and negative resistance effects, of course, the output goes through the roof. Let's hook up the detector next. The regenerative detector is hooked up again. Now I'm going to introduce some regeneration. As we get regeneration going, you can see we have all kinds of gain. Tuning, still important, but we can really soup up the gain. And this shows how negative resistance with a regenerative receiver increases gain throughout the system. Now everything's coupled together. It's very difficult to separate the output of the RF preamp from the input of the detector because we're into a tuned circuit and everything is inductively coupled. But you can clearly see that adding regeneration increases gain. CHU at 3.3. This is 75 meters at night.
Electrical lugs.
75 meter band at night. It's just about 6 o'clock, 6:30.
Stuff like that, and I put that all into the...
Now the RF gain control
the truck was just about full. I had
works very
a
well.
lot of, pieces of wire and stuff like that. And
Now it's rare for a regen to have such a great RF gain control without affecting the frequency. As usual, you put the regen beyond the point of maximum sensitivity for the best product detection on sideband. It's most sensitive when you first go into regeneration, but your product detection won't be as good as if you go a little further.
I had buckets of those.
So you'll lose a bit of sensitivity by putting the regen clockwise more, but you'll gain some really nice sideband. Let's go down to CW. This is a CW signal with the wideband filter. That extra filtering makes the CW sound great on the receiver. This thing would be a perfect receiver for novice use on 80 or 40 meters, no problems at all.